Okay, for this exercise dealing with the law of sines, there's going to be two possible triangles here. Because if you did any reading about this, you know about the ambiguous case, which means, and where that comes from is, I know that if you think back to our work we did earlier, I know that there's two angles that have the same sine. One's in quadrant one, one is in quadrant two, and if this is a 30-degree angle, this angle over here with a reference angle of 30 degrees will have the exact same sine or y value that the one in the first quadrant will have. So if you're going to keep that in mind, if you don't know the obtuse angle in your triangle, then you got to consider that it could be an obtuse angle that we're looking for, and not just the 30. So I would be looking for the 150-degree angle here. The reason this comes from, I don't know if you remember back in high school geometry, your high school geometry teacher had you solve, prove the triangles are congruent using side angle side and angle side angle and side side side. And what was there? There was angle angle side. But then they probably said, don't use SSA because that's not a congruence postulate. And the reason it's not a congruence postulate is because they didn't really go into detail. They just said it doesn't work if you assume, or that kind of thing. Okay, we won't go there. But see, the reason is if I've got a triangle, like let's look at this triangle here. Let's see, angle A is 47 degrees. Let's see, let me draw this out. Angle A is 47 degrees. And side A is 32. Remember, the angle goes across from the side goes across from the angle. And then side B is 35. I'm assuming this is side B. We'll just make it be side B. So here's angle B, and I want to find that. When I do this, when I set up my law of sines, I like to write the sine on top. So sine of 47 over 32 equals the sine of angle B over 35. And now if I grab a calculator and do that, let's see, I got to change this. I think I've got this calculator in degree mode or radian mode. Let's see, mode. Yeah, I got to change it to degree mode. I'm working with triangles and angles, so angles and degrees. So let's second quit. So then I'm just going to cross multiply divide. So what's 35 times the sine of 47? And I'm going to close that. Since this calculator does follow order of operations, I'm just going to go ahead and say divided by 32. And I get that for the answer. Now the trouble with that answer is, well, then I'm gonna arc sine that, right? I got to find the arc sine of that. So second, because that's what the sine of angle B is that decimal. So to find the angle for B, no, sorry, hit the wrong button here. Second sine, where's my arc sine? Right there. Whoops, I got to quit the screen. Second quit. So second arc sine, and because this calculator will let me do it, I'm just going to press my up arrow and press enter. So find the arc sine of that angle, and it tells me it's a 53-degree angle. However, it could be, okay, so what I've got going on here, just like I drew with the 30s, let's go over here. So I've got this thing going on. I just found the arc sine. It told me it was 53 degrees in so many minutes, so many seconds. Okay, but it could be an angle over here that has a reference angle of 53 degrees, and that'll have the same sine. So the trick is, and this my open math question is asking us to find the obtuse angle. They're telling us that this angle B will be the obtuse angle. So to get that angle, I have to do 180 minus my 53 whatever. Okay, so 180 minus my answer. So 126 point, let's see, how many decimal places are they looking for? See, one obtuse angle. So this is the flag that know that the angle B is going to be the obtuse angle. Well, I mean, it could be angle C, but it's coding, so they're looking for the obtuse angle. So 126.877. How many decimal places are they looking for? I will just type in a few to keep my math happy. 87772. And then just to check and see that I've got this right, then I'm going to do that answer plus 47. And that's the two angles. Now to find the third, I'm just going to subtract that from 180. So it was 6.122. I better get this right. Let's see, 122. I find what works well for my open math, and you probably have found this too, is to give it plenty of decimal places. I usually go till I don't have to round. Then we're going to find that missing side, that side C, and it's not a right triangle. Some people will try to do that, so we got to use the lost signs to finish that here. Let me get rid of my congruence and my non-congruence postulate there. So now, since I know angle C is, let's see, let me go to red ink here so I know what I'm working with. So angle C, whoops, go to a pen. Angle C is how big? 6.1. I'm just going to write down 6.1 on my drawing, but I'm going to actually use the full thing, and that's side C. So engineers like to use non-calculated values so you don't introduce rounding error, and actually that's probably pretty sound. So I'm going to use the sine of 47 over 32 that they gave me. 32, Dan. Let's see, 32. 32. I'm convinced. I haven't had enough coffee. That's the issue. Equals the sine of 6.1. Of course, I'm going to use the full value of my calculator over side C, and that will finish this off to solve this. So cross multiply, divide. So I'm going to do the sine of that answer, since I've got that right there in my calculator. I'm going to multiply that by 32. And then I'm going to divide that by the sine of 47. And that gave me 4.666 for that missing side. So let's try typing that in and see if we can get it. 4.666. And they liked them all. Okay, so hopefully that'll help you solve this problem.